Welcome to today's session. Today we'll be doing matrices and transformations, and I've already written the question down, so feel free to pause the video so that you can read the question. A woman owns 60 domestic animals. Each of her domestic animals is either a cow or a chicken. If the domestic animals have a total of 200 legs, use the matrix method to find the number of cows and the number of chickens that the woman owns. Okay, so that is our question. So let's start with the solution for the question. Solution. So our first step, step 1, get the simultaneous equations. Okay, so the question says a woman owns 60 domestic animals. Okay, each of her domestic animals is either a cow or a chicken. So let the number of cows be X and those of chickens be Y. Okay, so our first equation will be a simple one. X plus Y equals 60. This is because the total number of animals that the woman owns is 60. Okay, our second equation, if the domestic animals have a total of 200 legs, which means for each cow there are 4 legs, so 4x plus each chicken has 2 legs, so 4x plus 2y equals 200. Okay, now we can simplify equation number 2 into, by dividing by 2 on each piece of the equation, we are left with 2x plus y equals 100. So these are our two equations. X plus y equals 60. 2x plus y equals 100. Okay, now that we've gotten the equations, let's proceed with step number 2. So step 2, what are we doing in step 2? Step 2, we are now arranging the equations in matrix form. Okay, so our equations say x plus y equals 60, then 2x plus y equals 200. Okay, into matrix form, this becomes 1, 1. This is a 1, 1, 2, 1. X, y equals 60, 200. Okay, so our matrix is now 1, 1, 2, 1. X, y equals 60, 200. Okay, now step number 3, compute inverse of pre-multiplier. This here is the pre-multiplier, so we need to compute the inverse of this matrix. let A be equal to 1 1 2 1. Okay, therefore inverse of matrix A equals to 1 over determinant of A times rearranged matrix. Okay, so let's rearrange this matrix. What happens is we interchange the elements of the main diagonal and we change the value of the numbers of the anti-diagonal from negative to positive and positive to negative. So our rearranged matrix, will be 1 1 negative 2 negative 1. Okay, now determinant will be equal to 1 times 1 minus 2 times 1. This equals negative 1. So our determinant is negative 1 and our rearranged matrix is right here. So the inverse will be 1 over negative 1 times 1 negative 1 negative 2 1. So the inverse of the matrix will be negative 1 1 2 negative 1. So this here is our inverse. Moving on to step number 4. Step 4. What follows is now we pre-multiply the inverse on both sides. Okay, so we have our inverse. We pre-multiply it from the matrix equation on both sides. So we have negative 1 1 2 negative 1 times 1 2 1 1 x y equals negative 1 1 2 negative 1 times 60 200. Okay, so on this side we're going to have what we call the identity matrix, okay, which is 1 0 0 1 x y equals, on this side we need to multiply, so it's row times column. So we have negative 60 plus 200, and the bottom one is going to be 120 minus 200. Okay, so if anything times the identity matrix equals to itself, so x y equals to, if you compute here you get 140 minus 80. So this, so answer x equals to 140, y equals to 80. That's the solution for this question.